Alright, today I'll talk about the problem money systems. In this problem, we cannot use recursion because it says that this total will fit into a signed long, which means that it can be way much more than 10 to the power of 9. It can go all the way to 10 to the power of 18. And that's going to take too long for us to loop through. So we can use dynamic programming in this problem to keep track of previous combinations and add them up all the way till our number n. So I created this dynamic programming array. This is the maximum size of n. So I added a few just in case of overflow or anything, but of course that probably wouldn't happen. And after reading the input, I set dp0 to 1. This means that the number of ways you can find by combining the coins to get 0 is equal to 1 because that is really simple. Of course, the only way to get 0 units from the coins is by not choosing anything. So there's only one way to get 0. And then from here, you'll create a nested loop. This outer loop is looping through each of our coins. And the inner loop will loop through each of our number from 1 to n. N is the number that we want to get at the end. So first we have to check if coin I is smaller than or equal to j, because you cannot subtract a coin that is greater than j, because you can't have negative amount of money. And if it is smaller, then we will add the number of ways we can get by subtracting j from by subtracting coin I from j. So what this does is that it will find all the previous ways you can the ways that you can get j minus coin I from. Because for example, if we want to get 5 and our coin I is 2, then 5 minus 2 is 3, and we will add the number of ways that we can get 3 from. And what that does, because we know that no matter what, we will just add a coin afterwards, so then that wouldn't change any ways of probabilities or anything. So we just add this up every time we find a new coin, and then we'll go through this loop every time. If you try putting this inner loop outside and using the outer loop as the inside one, which means that the outside loops from 1 to n and the inside loops through each of the coin every time, that wouldn't work because you will have overlapping cases. For example, you would have already visited a few of the numbers, but then, for example, you might have visited 112, but then if you have this loop that's constructed the other way, you will loop through 121 again. And that is the same thing as 112. So if you've already looped through 112, you don't want to go back to 121 because they add up to the same thing. So you can keep the money loop on the outside and the total sum loop in the inside, and that will get us a proper answer. And finally, print out dpn, which is the number of ways that we can arrange the coins to get to n units.